Hey guys, this is teacher Tanya speaking, and today we are talking about how to use the Rubik's Cube in math class and the benefits of Rubik's Cube for learning. So, is it just a toy? A distraction in the classroom? That's what some dinosaurs think. But the Rubik's Cube is one of the most powerful learning tools you can bring into a math class. So, get ready to discover the amazing connection between the Rubik's Cube and math. Trust me, it's way more than just a puzzle. Give me a thumbs up if you don't have a clue of how to solve it. Let's get one thing straight. This little cube is a powerhouse of mathematical concepts, all wrapped up in a fun and colorful package. It's a challenge that requires geometry, symmetry, and some serious problem solving skills. Let me know in the comments if you already know how to solve it. When you are twisting and turning these layers, you're not just randomly hoping for the best. You're developing your logical thinking and the ability to solve problems. So you learn to strategize and think ahead. Let's break it down. First up, geometry and symmetry. Each little piece, or cubie, is a part of a larger whole. You have center pieces that only rotate, edge pieces with two colors, and corner pieces with three. Understanding how these pieces move in 3D space is a hands-on geometry lesson. We're talking about rotations, translations, and understanding spatial relationships without a single boring worksheet. And the symmetry? A solved cube is a beautiful example of symmetry on all its faces. Next, we have the super cool world of permutation and algorithms. Sounds complicated, right? But it is not. A permutation is just a fancy word for arranging things in a certain order. And with over 43 quintillion possible arrangements, this cube has a lot of permutations to solve it. We use algorithms. An algorithm is just a set of steps to follow and solve a problem. In cubing, we learn specific sequences of moves to get the pieces where we want them to go. It's like a secret code that unlocks the cube's solution. This is the same kind of thinking that computer programmers use to write code. So yeah, your kids are basically becoming mini coders. But the benefits of Rubik's Cube go way beyond math equations. We're talking about building character. We practice skills like patience and perseverance. Let's be real. You're not going to solve this thing in 5 minutes on your first try. And that's okay. The struggle is part of the learning process. But let me know in the comments if you did it in the first time because it will be super amazing. You first need to understand the structure and how the pieces relate to each other before you can apply the algorithms. And when you finally solve it, that feeling of accomplishment is huge. It builds self confidence like nothing else. It teaches students that with dedication and practice, they can tackle even the most daunting challenges. Now, here's the part that gets me really excited. The Rubik's Cube is an incredible tool for celebrating diversity in the classroom. Think about it. The cube is a universal language. It doesn't matter what language you speak at home or where you come from. There are no words to read, just colors and patterns. That make it incredibly accessible to students from all backgrounds, including English language learners. It also caters the different learning styles. For our kinesthetic learners, it's a hands-on tactile experience. For visual learners, the colors and patterns are a key. And for our logical thinkers, the algorithms and problem solving are a perfect fit. And think of this. By working together on a collaborative project like a Rubik's Cube mosaic, students learn teamwork, communication, and that every single person's contribution is vital to creating something beautiful. It builds a sense of community and shared accomplishment. Each cube is a small part of a bigger picture, just like each student is a unique and valuable part of our classroom community. So, hands on, Teacher Tanya, you inspire me so much. Now every student has a cube. Now what?
Don't just hand them out and say, solve it. That leads to frustration. Instead, structure the introduction over a few days. Before they start bringing their cubes, make them curious by letting them watching you solving it. Kids learn by modeling, and seeing that you are trying to solve it is very fun for them. When they bring it, it's all about exploration. The only goal is to get familiar with it. Have students answer simple questions. How many colors are there? How many squares are on each face? Guide them to discover the three types of pieces, the center ones, the edge, the corners. Have them find all the corner pieces. Have them count the edge pieces. This is a hands-on lesson in observation. The disassemble day. They usually disassemble it by themselves, so this is often the most memorable day. With supervision, let your students carefully take the cube apart. Yes, take it apart. They'll see firsthand how the core mechanism works and how the pieces connect. It completely demystifies the puzzle. Their task is to reassemble it in a solved state. This single activity builds confidence and gives them a foundational understanding of the cube's structure. Then let the real challenge begins. Your goal for the week is not to solve the whole cube, but just one layer. Focus on one color, like white. Teach them the first goal. Create a daisy, the yellow center with four white edges pieces around it. Then teach the simple algorithm to flip those pieces down to form a white cross. Celebrate this as a massive victory. From there, guide them to insert the white corner pieces correctly or collect the puppies. By the end of the week, many students will have a full white layer solved, giving them a huge boost of confidence and the foundational skill needed for the rest of the cube. Once your students are hooked, you can explicitly connect the cube to your math curriculum. Use the cube as a physical model for 3D coordinates. Define the front face as the x-axis, the top face as the y-axis, and the side face as the z-axis. When you call out a thorn like R for the right face, you can explain it as a 90-degree clockwise rotation on the x-axis. This makes abstract concepts of rotation and axis tangible for them. Then talk about the superpower of the cube. Frame algorithms as recipes. Say, we have two corner pieces that need to swap places. We can just move them. We need to follow a recipe for movings, an algorithm to let the results that we want. You can have students write down the notation for a simple algorithm, then have them perform it on their cube to see the outcome. They are learning the core principle of coding. A specific sequence of commands produce a predictable result. You are not just solving a puzzle, you are executing a program with your hands. For problem solving, use the cube to teach the most important skill of all. Breaking a massive, overwhelming problem into smaller, manageable steps. The problem isn't solve the Rubik's Cube. The problems are first, solve the white cross, second, connect the puppies, third, solve the middle layer, and then the final layer. Frame your lessons this way. Create a chart where students can track their progress through these stages. They learn that every complex problem can be conquered by breaking it down. Now you can use it as a morning warm up activity where everyone can silently work and focus. In the other hand, it doesn't have to be a solo activity. Create group challenges. Give a team of 4 students 4 scramble cubes and challenge them to be the first team where everyone has a solved first layer. Or better yet, try Rubik's Cube mosaics. Print out a pixelated design where each pixel is a solved cube face. Each student is responsible for creating 1 or 2 pixels with their cube, and together the class assembles a large, beautiful piece of art. This teaches teamwork and shows how every individual contribution is essential to the bigger picture. Remember to celebrate progress, not just speed. Avoid making it all about who solved it fastest. Not everyone will be a speed cuber, like my amazing Paulina, who was the inspiration to start using the Rubik's Cube in class. Oh, who said that? And if you are a speed cuber, that's okay, but create a cube mastery chart in the classroom. So the levels could be: I can make a daisy, I solve the white cross, I collect the puppies, I can solve the middle of the cube, I can solve the whole cube. So the students can put a sticker next to their name and see each milestone that they reach. This celebrates the process. So the next time someone asks you why you're playing with Rubik's Cube in class, you can tell them that you are teaching geometry, computational thinking, and perseverance, that you're building confidence, and most importantly, you are creating a classroom where every student, regardless of their background or learning style, has a colorful, hands-on way to succeed. Don't be a dinosaur. Unleash the power of the cube in your classroom. You'll be amazed. So, to all the teachers, the parents, and yes, even the dinosaurs out there, I say this: let them play, let them twist and turn, let them get frustrated, and then let them feel the triumph of solving it. Of course, play with them. In conclusion, if you want to help your students become better mathematicians, more resilient learners, and more inclusive individuals, introduce them to the magic of the Rubik's Cube. It's more than a toy, it's a tool for building brighter minds and a more connected world. And of course, if you found this helpful, leave your thumbs up and let me know in your comments if you have already used the Rubik's Cube in class. Little monsters, keep on playing. See you soon!